Hello again, and welcome to the Sleepy Atom. Tonight we drift slowly, not to a gas giant or icy moon, but towards something much smaller and much quieter. A planet so close to the Sun you'd expect it to roar, but instead it whispers. Mercury, the first stone from the Sun, is a world of deep stillness, strange rhythms, and silent scars from the past. It doesn't wear rings. It doesn't have storms. It doesn't even have a real sky. Just the hard face of stone, staring back at the sun. Its days last longer than its years. Its craters are older than bones. And yet, most people never really think about Mercury. Maybe that's because Mercury never tries to be noticed. But tonight, you'll notice it. As you settle in, let your thoughts wander to a place where light is too bright to bear, where shadows freeze for eternity, and where the planet itself spins so slowly you could walk faster than the sunrise. We'll explore Mercury softly, from the cracks in its crust to the timeless echo of its orbit, not to memorize facts, but to feel something strange and quiet and beautifully forgotten. Let's begin, together. Why Mercury doesn't shine in the night. Mercury is the closest planet to the Sun, but it's also one of the hardest to see with your eyes. That might seem odd, right? Something so close to the source of light, and yet nearly invisible in the night sky. But there's a reason for this strange shyness. Mercury never strays far from the Sun in our view. It rises only just before dawn or sets right after sunset, always hiding in the Sun's glare, always just out of reach of full darkness. Even when Mercury is bright, and sometimes it can outshine stars, it's caught in twilight, the brief window when the sky is neither dark nor light, by the time the sky gets truly dark enough to gaze at stars. Mercury is already gone, ducked back behind the horizon, quiet as ever. You could spend your whole life looking up, and never notice it was there all along. And maybe that's why Mercury feels like a secret. A cosmic whisper at the edge of vision. Something you have to be patient for. Astronomers sometimes call it an elusive wanderer, because to see it, you must time it just right. You have to know where to look, and when. But those who have seen it, rising just before the Sun like a small silver coin, say it feels magical. Like you've caught a glimpse of something ancient and fast. A runner at the starting line of the solar system, glowing just once before the curtain closes again. And that's how we begin. With the planet that rarely performs, but always listens. The planet that hides in plain sight. The one that never asks to be remembered, and yet tells the first chapter of our solar system's story. The closest planet to the Sun. Mercury is the innermost planet. That means it orbits closest to the Sun, just 58 million kilometers away. That might sound like a lot, but in cosmic terms it's practically hugging the fire. If you stood on Mercury, the Sun would look almost 3 times larger than it does from Earth, and far more intense. Not warm, but overwhelming. Despite that closeness, Mercury doesn't burn. Why? Because it has no air, no atmosphere to trap heat or spread it around. So while one side of Mercury bakes at 800 degrees Fahrenheit, the other side, in shadow, can freeze to -300. It's a planet of extremes, with no soft middle. Because it's so close to the Sun, Mercury also moves fast. It races around its orbit in just 88 Earth days. That's 1 year for Mercury, the shortest in the entire solar system. Blink, and Mercury's already lapped you. It's the cosmic sprinter, circling the finish line before Earth is even halfway there. But here's the strange part. For all that speed in orbit, Mercury rotates incredibly slowly. It takes almost 59 Earth days just to turn once. That means if you stood on its surface, sunrise would creep across the land slower than you could walk. The contrast is almost poetic. racing in circles while barely turning at all. This odd dance between fast orbit and slow spin makes Mercury feel like a paradox, a planet in a hurry, but with nowhere to go, a stone so close to the sun, yet so slow to turn its face toward the light, a day that lasts forever. A single day on Mercury, from one sunrise to the next, lasts 176 Earth days. Let that sink in. That's nearly 6 Earth months just to complete one day-night cycle. Time flows differently on Mercury, almost like a dream where nothing changes for weeks. The sun rises slowly, crawls across the sky for months, and then finally sets. And in between, the planet barely turns. Imagine standing there, watching the same rock cast the same shadow for weeks, never moving. It's almost like time has stopped. But the reason this happens is rooted in gravity's strange grip. Mercury is locked in something called a 3-to-2 resonance. It spins on its axis 3 times for every 2 orbits it makes around the Sun. This gravitational rhythm creates the slowest day in the inner solar system, a whisper of motion in a world full of light. There's something peaceful about it, though. Mercury doesn't rush. It doesn't spin wildly or toss clouds around. It turns with grace, like an old dancer still moving, but only when it's ready. It waits. And when it does finally greet the sun again, the light falls like a long-forgotten memory. In a world where everything spins faster, Mercury reminds us that some things take time, that even the slowest turn can still carry you forward. The slowest spin in the inner solar system. Mercury rotates so slowly, its day is longer than its year. That simple fact feels like a riddle. But it's true. While it orbits the Sun in just 88 days, it takes nearly 59 days just to turn once. That means during most of its year, the same side of Mercury is staring at the Sun, patiently baking. No clouds race across its sky. No winds howl through canyons. There's nothing to hurry it along. The whole planet feels like it's caught in a deep breath, holding still as time walks past. This slow spin was likely sculpted by the Sun itself. Over billions of years, the Sun's gravity tugged on Mercury, not to stop it, but to slow it, bit by bit, until Mercury found a rhythm, a compromise between orbit and spin. That compromise is what keeps it locked in its 3-to-2 dance. This gentle spinning, this soft turning, is not just a quirk, it's a signature. It means Mercury shows the same faces to the Sun over and over again, like a stone in a slow orbit around a campfire, turning just enough to warm each side, one at a time. And that's why standing on Mercury would feel timeless. Because everything moves so slowly, so predictably, it might feel like nothing is happening at all. But beneath that stillness, something ancient is always turning. Sunrise, every 176 Earth days. Imagine waiting half a year for the sun to rise, and then watching it crawl across the sky in slow motion. That's life on Mercury. With its slow spin and fast orbit, Mercury experiences one sunrise every 176 Earth days, a single dawn that lasts as long as an earthly season. The sunrise itself would be like no other. The sun wouldn't just rise, it would stretch, pause, even appear to move backward before climbing higher. That's how warped time and motion become here. A day on Mercury isn't just long, it's beautifully strange. Because Mercury's orbit is so elliptical, stretched like an oval, the speed of its motion changes constantly. Sometimes it moves faster, sometimes slower. That changing pace means the sun's path across the sky doesn't make sense in a normal way. It stops, reverses, dances. If you stood in one of Mercury's craters during this odd sunrise, you might start to forget what normal meant. Time would feel soft. Light would feel heavier. and the sound, or rather the absence of it, would make the whole world feel like it's holding its breath. And maybe in that long, quiet moment, you'd feel something ancient pressing against your heart. The gentle rhythm of a planet that spins in silence, just waiting for you to notice it. 1 year, 2 sunrises. Mercury is the only planet where you can see the sun rise, and then rise again, before it ever sets. It sounds impossible, but on Mercury, time and space move differently. As the planet orbits the sun in just 88 days and rotates in a strange resonance, the result is a sky that plays tricks on you. If you stood on the surface near the right spot, you'd see the sun begin to rise, then stop, drift backward, and rise again, all during the same long, slow day. It's not just the strangest sunrise in the solar system, it's 2 for the price of 1. This double sunrise happens because Mercury's orbital speed changes as it swings closer or farther from the sun. Sometimes it moves fast enough that its orbit outpaces its own spin. That causes the sun to appear to reverse course, not because the sun is moving, but because Mercury's motion is wobbling beneath you. What would it feel like to witness that? To stand in the silence of a world without wind or noise and watch the most powerful star in the sky, hesitate? Perhaps it would feel like time itself was bending around your shoulders, tugging gently at your understanding of morning. On Mercury, even the sunrise is a gentle illusion, not a mistake, but a quiet reminder that nothing in the universe moves in straight lines or simple rhythms. Not light, not planets, not even time itself. Mercury's orbit is an egg, not a circle. If you could draw Mercury's path around the sun, it wouldn't be a neat circle. It would look more like an egg, stretched slightly, almost oval-shaped. Scientists call it elliptical, but it's more than just a shape. It's a story of imbalance carved into space by gravity itself. Unlike Earth's nearly round orbit, Mercury's ellipse is more exaggerated. That means sometimes it's much closer to the sun, and sometimes it's farther away. The result? Intense shifts in solar energy, huge changes in speed, and a sky that never acts quite the same way twice. When Mercury swings close to the sun, it speeds up dramatically, racing along its orbit like a stone slingshot around a campfire. But as it pulls away, it slows again, gliding in slow curves, drifting through shadows. That constant acceleration and deceleration causes strange effects in the way the sky looks from the ground. Mercury's egg-shaped orbit is also the reason we get the strange double sunrise, and why its temperature extremes are so brutal. The closer it gets to the sun, the more violently it bakes. But when it drifts away, the heat disappears instantly, leaving behind ice-cold shadows where light will not return for months. In that way, Mercury teaches us something quiet but powerful. Not all journeys are smooth. Sometimes the path bends, stretches, flattens, and yet still returns. Not in a perfect loop, but in a rhythm that somehow still works. Einstein and the wobble of Mercury. In the 1800s, astronomers noticed something strange about Mercury's orbit. It didn't move exactly the way Newton's laws predicted. There was a wobble, a tiny drift in its closest point to the sun. Year after year, it shifted just a little more than expected. Not a lot, but just enough to leave scientists puzzled. They checked for hidden planets, calculated gravitational pulls, tried to fix the math, but nothing made sense until Einstein came along. In 1915, his new theory of general relativity, a radical idea that gravity bends space and time, finally explained Mercury's strange wobble. According to Einstein, the sun is so massive it actually curves space around it. Mercury, being so close, moves through this curved fabric like a marble on a warped sheet. Its orbit precesses, shifts slowly over time, not because it's broken, but because it's moving through bent space. Einstein's prediction matched Mercury's wobble exactly. It was one of the first major proofs of his theory. A tiny planet spinning in silence confirmed one of the greatest scientific ideas in human history. And it did so without trying, without speaking, just by being what it is. So when you think of Mercury, think of more than just a grey rock in space. Think of it as a quiet messenger, helping us glimpse the shape of reality itself without ever saying a word. No moon, no clouds, just space. Unlike Earth, Mercury has no moon to keep it company, no atmosphere to hold clouds or create colour. There's no sky to turn blue, no weather to break the silence, just an endless black above and a surface covered in ancient scars. A world so still, it almost feels like it's holding its breath. Without air, there's no wind, no sound, no rustling dust, and no protection from incoming rocks or radiation. Every meteor that strikes the surface leaves its mark, unsoftened, unerased. The craters stay forever, like footprints in concrete, frozen mid-step for billions of years. Mercury's silence is more than quiet, it's absolute. If you stood there, you'd hear nothing. Not even the faint hum of air around your ears. Just your own heartbeat, and perhaps the distant echo of a thought. But this emptiness isn't lifeless. It's alive in another way. In every crater is a memory. In every ridge, a forgotten chapter of the solar system's early chaos. Mercury carries these marks like tattoos, not of pain, but of survival. And so, though Mercury has no moon, no clouds, and no sound, it still tells stories. Not out loud, but through stone and shadow, through stillness. That speaks. A planet older than Earth's memory. Mercury is ancient, really ancient, formed over 4.5 billion years ago, around the same time as Earth, but its surface has barely changed since. While Earth has oceans, erosion, life reshaping the land, Mercury has remained frozen in time, a record of the solar system's youth carved in craters and cracks. Walking across Mercury would be like stepping back in time. You'd see terrain that hasn't shifted in eons. Lava plains long cooled, craters untouched, ridges formed as the planet shrank, its metal heart cooling like a quiet fire finally dimming. Because it never had active plate tectonics or weather, Mercury's past remains on full display. A gallery of ancient violence preserved by the silence of space. It's like finding a scroll written in stone, where every dent is a story. Some scientists even believe Mercury's surface might be the oldest solid crust in the solar system. That means it holds clues about how all the planets, including Earth, came to be. By studying Mercury, we're not just learning about a distant world, we're learning about our own beginnings. And in that way, Mercury becomes more than just a quiet rock. It becomes a witness, a survivor, a softly spinning storyteller, whispering to anyone willing to listen. 800 degrees by day, negative 300 by night. Mercury has the most extreme temperature swings of any planet in the solar system. And yet, it has no heat of its own. Its days reach nearly 800 degrees Fahrenheit, hot enough to melt lead. But at night, those same rocks freeze to minus 300. A swing so violent, it feels like fire turning instantly into ice. Why does this happen? It's because Mercury has no atmosphere to hold the heat. When the sun rises, the surface bakes under direct radiation. And when it sets, there's nothing to keep the warmth from escaping. Heat comes fast and vanishes just as quickly. Standing on the day side would feel like standing inches from a furnace, with no air, no shade, and no wind. But walk far enough into the shadow, and your footprints would freeze. The silence would be the same, but the temperature could drop hundreds of degrees in just a few steps. This creates a strange world where opposites live side by side, light and dark, hot and cold. Day and night are not just times of day, they're entirely different realities. Two planets, sharing one face, and somehow Mercury endures it all, unchanged, as if it has come to accept both extremes, not resisting either, just rotating slowly through them, again and again. How a planet bakes and freezes. On Earth, heat travels. The air moves it, the wind spreads it, even clouds carry it around. But on Mercury, there is no such sharing. Each rock sits alone under the sun. Each shadow hides in perfect stillness. There is no weather, no breeze, no movement. Just intense heat and intense cold, existing side by side. Mercury's surface is made of dark volcanic rock, the kind that absorbs sunlight like a sponge. When the sun hits it, that energy soaks in fast. The ground can become hotter than the inside of an oven in just a few hours. But when night falls, the curtain drops. Without an atmosphere, that same surface begins losing heat immediately. There's no insulation, no blanket, just the emptiness of space, stealing warmth molecule by molecule. In a matter of hours, glowing rock becomes frozen dust. What's fascinating is how still this whole process is. On Earth, we'd feel heat waves shimmer, or winds begin to stir. But on Mercury, nothing stirs. The heat just arrives, and then vanishes, like a ghost passing silently through the stone. It's not chaos, it's choreography, a rhythm between fire and frost, one that has repeated for billions of years, without ever once raising its voice. The craters have names like poems. Mercury's surface is covered in craters, not just a few, but thousands. And they aren't named after generals or politicians, they're named after artists, writers, composers, poets. On Mercury, silence is carved with the names of creativity. There's a crater named Beethoven, another called Shakespeare. There's Rembrandt, Matisse, and even Hemingway. All across the surface, etched into the crust, are tributes to human imagination. It's as if, on a world without life, we left our artists to watch over it. This naming tradition began with a simple idea. If Mercury is silent and ancient, let it honor those who gave humanity its voice, the ones who helped us feel wonder, even in the darkness. A crater becomes a canvas. A scar becomes a stanza. Imagine walking through the Calvino crater, named after the surreal Italian writer, or standing at the edge of the Ovid Basin, staring into silence where once words were sung. It doesn't feel like a graveyard, it feels like a library carved in stone. Mercury, though voiceless, holds these names like soft echoes. The surface may be quiet, but the spirit of creativity lives on in each crater's rim, waiting patiently to be remembered. Why Mercury has ice at the poles? You wouldn't expect to find ice on the planet closest to the Sun, but Mercury always finds a way to surprise us. In its north and south poles, deep inside craters that sunlight never touches, there is frozen water, ice, cold, shining and ancient. These polar craters are so deep and Mercury's tilt is so minimal that sunlight can't reach the floors. The walls create permanent shadows, shielding the ground from heat. These shadows act like vaults, keeping the cold locked in for eons. The ice there isn't like our snowy hills. It's likely mixed with dust, buried under rocks, or clinging to the sides of crater walls. But it's there, confirmed by radar, proof that even in a place scorched by the sun, cold can still survive. Where did the ice come from? Possibly from ancient comets, icy travelers that crashed into Mercury long ago, or maybe from water deep underground, slowly leaking out and freezing in the shadows. No one knows for sure, and that mystery is part of what makes it beautiful. A world without clouds, without rain, yet somehow it has ice, proof that even the hottest places can still hold on to something cool, quiet, and hidden. Shadows that last a million years. In some of Mercury's polar craters, there are places where the sun has not touched for millions, maybe even billions of years. These aren't just dark spots, they're ancient shadows, so deep, so perfectly placed that light has never brushed their surface. The tilt of Mercury's axis is less than 1 degree. That means the sun never climbs high in its sky. Especially near the poles, the light always grazes sideways, casting long, low shadows that never move, never fade, never shift. Inside those shadows, the temperature stays cold enough to preserve ice, to freeze molecules, to lock dust in place. Nothing stirs, no light enters. These are among the most untouched places in the entire solar system. What would it feel like to stand at the edge of one, to look into a pit of eternal dark, not as something fearful, but something sacred? Perhaps it would feel like peering into time itself, into a moment that hasn't changed since before Earth had oceans, and maybe that's Mercury's quiet gift to us, to remind us that not everything needs light to matter. Some truths live best in shadow, untouched, unspoken, but never forgotten. The deepest hole in the solar system, hidden in Mercury's southern hemisphere, lies a colossal basin, one of the largest and deepest in the entire solar system. It's called the Caloris Basin, Latin for heat. But strangely, it isn't just known for heat, it's known for its depth, a wound in stone so vast it could hold an entire country inside. Over 900 miles wide and nearly 3 miles deep. This impact basin was created by a single catastrophic collision billions of years ago. A space rock, possibly 60 miles wide, slammed into Mercury at unimaginable speed, carving the surface like a slow-motion explosion frozen in time. Standing at its edge would feel like standing at the rim of a forgotten world. The crater walls rise like broken mountains. Ridges twist outward, and inside, molten plains have frozen solid, smooth, silent, and untouched for eons. Nothing grows here, but everything remains. The force of the impact was so immense it rippled across the entire planet. On the opposite side of Mercury, the shock created chaotic terrain, cracked, jumbled land that looks like shattered glass. It's as if the entire world rang like a bell, and never quite recovered. And maybe that's why Mercury feels so introspective. A quiet planet with a deep memory, one whose scars run not just across its face, but through its heart, a place without wind. If you stood on Mercury and held your breath, you'd hear nothing, not just silence, but a kind of emptiness, a stillness that goes beyond sound. Because Mercury has no wind, no air to carry a breeze, no atmosphere to rustle the dust. It is a place without breath, and that means the surface is untouched by erosion. Craters don't fade, rocks don't smooth, dust doesn't drift in patterns. Everything that hits Mercury stays exactly where it lands, undisturbed, unchanged, unmoved. A footprint placed in the dust might last a million years, not because time stopped, but because nothing else will come to wash it away. No rain, no gust, no weather, just the long, slow fall of time pressing gently down on every rock. It's strange to imagine a world where wind never blew, where no sky ever roared. But in that stillness, something else takes shape, a kind of patience, a sense that Mercury is listening, not to the noise of the world, but to the quiet inside it. And maybe that's something we forget, that not every place needs motion to be alive. Some places, like Mercury, exist as reminders that stillness can be a form of strength. Micrometeorites that whisper across the surface. Even in Mercury's silence, something stirs. Tiny space rocks, micrometeorites, fall constantly onto its surface. They're smaller than pebbles, often no bigger than grains of sand. But in the vacuum of space, with no atmosphere to slow them down, they arrive like bullets wrapped in quiet. Each one crashes at incredible speed. There's no air to burn them up, no clouds to catch them, just open space and ancient rock. When they land, they chip the surface, stir the dust, and leave tiny marks that accumulate slowly, like whispers etched into stone. Over time, this endless bombardment darkens the crust. It's called space weathering, not wind or rain, but the constant kiss of falling debris. The ground becomes smoother, darker, quieter, covered in a layer of ancient ash from space itself. This is the only kind of weather Mercury knows. Not clouds or storms, but falling stars. A soft, ceaseless drizzle of stone, changing the surface ever so slowly, one grain at a time. So while Mercury has no wind, no rain, it still feels the sky. Not through sound, but through touch, like a planet being remembered by the universe around it, a surface that hasn't changed in billions of years. On Earth, the surface is always changing. Mountains rise, rivers carve canyons, forests grow and vanish. But Mercury is different. Its surface looks nearly the same as it did 3 or 4 billion years ago, a record sealed in rock. There are no oceans to shift its shores, no rain to wear down cliffs, no plate tectonics to fold its land. Instead, Mercury has been still for so long, it has become a kind of time capsule, a frozen snapshot of the early solar system. Scientists study Mercury not because it's exciting, but because it's unchanged. Its craters hold secrets. Its plains whisper of lava floods from a time when planets were still forming. Every ridge, every crack, every impact tells a piece of the story we thought we had forgotten. There's something beautiful about that. A world that refuses to erase its past. It doesn't rewrite itself. It remembers. Patiently, quietly, like an old soul that has seen too much and decided to simply be. To walk on Mercury would be to walk through history itself. Not a museum, but a memory you could feel under your feet. Sunrises that stretch for months. We often think of a sunrise as a quick thing, a warm flicker across the sky, gone in minutes. But on Mercury, the sun takes its time. It stretches. It hesitates. It rises slowly over weeks, like a curtain that refuses to be pulled back too fast. Because of Mercury's slow rotation, the sun seems to crawl across the sky. At the right place on the surface, you could watch the sun begin to rise. Stop, move backward, and then continue. A strange ballet of light, directed by gravity and timing. During this long sunrise, the ground beneath you would begin to glow. The shadows would stretch like ribbons, but the heat wouldn't arrive immediately. First there would be light, then warmth, then silence, still, but brighter. It's not just a sunrise, it's an experience, something to be felt, not just seen, like watching the beginning of time unfold slowly in front of your eyes, not rushing you awake, but inviting you to drift with it. And maybe, as the light slowly washes across Mercury's rocky face, you'd feel something inside you stretch too, something quiet, something old, a kind of peace that only comes from watching the sky take its time, a core that shouldn't be so big. Mercury has a secret buried deep inside, one that's puzzled scientists for decades. Its core, the metallic heart at the center of the planet, is far too large for a world its size. In fact, over 80% of Mercury's diameter is made up of core. That's like finding a tiny egg made almost entirely of yolk. Compared to Earth, Mercury's outer crust is just a thin shell. Its rocky surface is stretched over a massive ball of iron and nickel, like a delicate skin over solid metal. This makes Mercury the densest rocky planet in our solar system, despite being the smallest. Why is its core so huge? Some scientists believe Mercury used to be a much bigger planet, until something catastrophic happened. A violent impact in the early days of the solar system may have stripped away much of Mercury's outer layers, leaving only its inner metal sphere. Others think the intense heat of the young sun may have boiled off Mercury's lighter materials over millions of years, causing it to shrink into the dense, compact world we see today. Either way, the result is the same. A planet built like a cannonball, spinning slowly in the light. And somewhere in that oversized core, the story of Mercury's ancient past continues. Quiet, pressurized, and still, pulsing beneath the silence. Why Mercury might be a ghost of a bigger planet. If you could rewind time billions of years ago, Mercury may have looked very different. It might have been twice its size. A young world with a full rocky mantle and a thick crust, just like Earth or Venus. But then something changed. One theory says a planetary collision stripped it bare. A young protoplanet, perhaps the size of Mars, slammed into Mercury, shattering and scattering its outer layers into space. What was left behind was the core, the densest, deepest part, like the fossil of a world that once was. This isn't just poetic, it's supported by Mercury's unusually high density and small size. It looks like a planet that's been carved down, reduced to its bones. Like the sun's gravity or some ancient violence stole its skin and left behind only the muscle. If true, Mercury isn't just a planet, it's a survivor, a relic of chaos, a ghost of something bigger that once danced through the solar system, only to be shattered into silence. There's something haunting about that idea, that Mercury, so quiet and small, may carry the weight of a lost world within it, like a whisper from a history no one else remembers. The mystery of the missing mantle. We know what Mercury is made of now, mostly iron, some rock, and very little in between. But the puzzle lies in what's missing. Its mantle, the thick rocky layer that most planets have, seems to be almost entirely gone, thinned, erased, like a page ripped out of a book. Earth's mantle makes up most of its bulk. It shifts, flows, fuels volcanoes. But Mercury's is a shadow, thin, fragile, barely clinging to the metallic sphere underneath, and no one knows where the rest of it went. Some theories say that intense heat from the early sun vaporized the lighter rock, boiling away Mercury's mantle before it even had time to cool. Others believe in a violent impact that knocked the mantle off into orbit, never to return. Either way, what should be there, isn't, and what remains? A crust of rock, pitted and fractured, stretched thin across a dense metallic world. A surface that remembers being full, and now feels just slightly incomplete. But even in its missing pieces, Mercury holds meaning. It shows us how unpredictable planets can be, how some become forests and oceans, while others become bones and echoes. Not every planet finishes its story the same way. A metal world with a magnetic heart. Despite being so small and quiet, Mercury has a magnetic field. That's rare. Venus doesn't have one. Mars barely does. But Mercury, this airless rock spinning in silence, still produces an invisible shield, flowing out from its core like a soft heartbeat. Its magnetic field is weak, only about 1% the strength of Earth's, but it's there, protecting the surface from solar wind, guiding charged particles, creating a soft magnetic bubble in space. And all of it comes from deep within its core. Scientists believe Mercury's core is at least partly molten, liquid iron slowly spinning, generating currents, which create magnetic forces. It's like a cosmic dynamo, a generator wrapped in stone, a system still alive, even after billions of years in the cold. This discovery surprised everyone. A tiny world with such a giant heart, still active, still humming. It shows that even planets that look dead on the outside might still carry movement inside, quiet rhythms, hidden life, of a different kind. And so, Mercury's magnetic field becomes more than just science. It becomes a metaphor for inner strength, for the invisible forces that shape us, even when no one's watching. Magnetic fields without a molten mantle. Normally, a planet's magnetic field comes from deep beneath, from the movement of molten rock and metal swirling in layers. But Mercury's mantle is thin, almost gone, and yet its magnetic field still pulses on. That's what makes it so unusual. Without a thick mantle to insulate and help churn the core, you'd expect the magnetic field to fade. But on Mercury, something else is happening. Its outer core may still be spinning, maybe even layered, liquid above, solid below, with just enough heat and motion to keep the magnetic engine alive. It's a fragile balance, one that shouldn't work, but somehow does. Mercury's field is also asymmetric, stronger in the north than the south, like it's tilted, uncertain, or slowly fading with time. Still trying to hold on. Even more fascinating, Mercury's core may be laced with sulfur. That lowers the melting point, letting the metal stay molten longer. It's like the planet built a survival plan, a way to keep its inner motion alive, despite losing so much of everything else. And that, perhaps, is Mercury's quiet wisdom. It reminds us that strength isn't always loud. Sometimes it's hidden, humming, deep inside, a slow-turning sphere of persistence, beneath a skin of silence, a comet-like tail made of light. If you looked at Mercury with the right kind of telescope, not with your eyes, but with sensors that see ultraviolet light, you'd notice something strange. Mercury has a tail, a long flowing comet-like stream stretching millions of kilometers behind it. This tail is made mostly of sodium, yes, the same element in your kitchen salt. But here, it's not solid, it's glowing, electrified, and it leaks from Mercury's surface in soft waves, swept away by the solar wind like fireflies on the breeze. The sun constantly bombards Mercury with particles and light. That energy knocks atoms off the surface, a process called sputtering. These atoms escape, and instead of forming clouds, they stretch out behind the planet, forming a glowing yellow-orange tail. This tail isn't always the same. It flickers. It changes length. Sometimes it pulses, depending on solar storms. And you can't see it with the naked eye. It's too faint. But it's always there, whispering behind Mercury like a soft breath of light. It's a beautiful contradiction, a planet with no atmosphere, yet trailing a shimmering tail like a ghost. A reminder that even silence can leave a mark, long after the planet has passed. A planet without an atmosphere, but not quite. We often say Mercury has no atmosphere, but that's not entirely true. It has something much thinner, much more delicate. Scientists call it an exosphere, a near vacuum made of scattered atoms, drifting in space, barely clinging to the planet. It's so thin you wouldn't even feel it, not with your hands, not even with instruments. It's a wisp, a whisper, made of oxygen, sodium, potassium, and trace gases knocked loose by the sun's relentless radiation. Unlike Earth's atmosphere, Mercury's exosphere doesn't trap heat, or carry sound, or colour the sky. It doesn't swirl or roar or bend the light, but it moves, it flickers, it's stirred by solar wind, and dances softly around the planet, like mist that never settles. Every atom in Mercury's exosphere is temporary. They fall back, or drift away. It's a cycle, atoms constantly arriving and constantly lost, an atmosphere that's always vanishing and always being reborn. It's not air as we know it, but it's a kind of breath, a thin veil that tells us Mercury isn't entirely alone in the vacuum. There's still movement here, still presence, still a touch of something that says, I'm here, even if you can't see me. Sodium clouds that glow in the dark. One of the most enchanting discoveries about Mercury is that it shines, not just from sunlight, but from its sodium. This element, when knocked free by sunlight or micrometeorites, floats above the surface and glows like a golden halo. When scientists use ultraviolet filters, they can see vast clouds of sodium glowing in Mercury's exosphere. These clouds aren't stationary. They swirl, they drift. They are brightest on the day side and trail off into space with the solar wind. And during meteor showers, when space dust rains down harder, Mercury's sodium glow intensifies. The surface gets stirred, and more atoms rise. The clouds bloom, like ghostly blossoms in the vacuum of space. These sodium clouds don't cast shadows. They don't make Mercury warmer, but they add something else, a kind of mystique, a beauty you can't quite touch, a soft radiance born from bombardment. Mercury may not have sunsets or auroras, but it still glows, not with fire, not with lightning, but with quiet golden breath, swirling above a world that knows how to shine, even when no one's looking. A tail that changes with the sun's mood. Mercury's tail isn't fixed. It doesn't always stretch the same way. It doesn't always shine the same color. Why? Because it's deeply sensitive to the sun's mood. When solar storms rise, Mercury reacts. Solar wind, that constant stream of charged particles from the sun, acts like a painter and a broom. When it's calm, Mercury's tail is thin, gentle, graceful. But when the sun becomes restless, that wind blows harder, and the tail flares. Bursts of energy knock more sodium loose from the surface. The tail lengthens. It thickens. Sometimes Mercury seems to grow wings, light streaming far behind it, changing shape hour by hour like the trail of a speeding comet. And then, as the storm passes, it all fades again. The tail shrinks, the glow softens, the sodium settles, and Mercury returns to its quiet rhythm, as if nothing ever happened. There's something intimate about that, a planet so small, so quiet, that listens and responds to the sun's every whisper, not with words, but with colour, light and gentle release. A relationship built on energy and endless response. Why Mercury's silence is never still. It's tempting to think of Mercury as frozen, still, dead. But silence doesn't always mean nothing is happening. In fact, Mercury is alive with subtleties, movements too small to hear, changes too faint to see, a ballet of atoms, hidden beneath stillness. Its surface is constantly struck by micrometeorites. Its exosphere is reborn with every sunrise. Its tail shifts with every solar wind. Its magnetic field pulses in asymmetry. And beneath its crust, its core may still swirl like liquid metal, slowly keeping time. Mercury teaches us something profound, that silence can hold movement, that emptiness can carry beauty, that a place with no wind, no rain, and no voice can still glow, still pulse, still endure. It's not a loud planet. It doesn't erupt or flash or sing, but it listens, it responds, it reflects. And maybe that's its greatest gift, to remind us that presence doesn't need to be obvious, that sometimes the quietest places hold the richest echoes. Mercury's orbit is not a circle, it's a dance. If you were to trace Mercury's path around the sun, it wouldn't look like a perfect circle. Not even close. It would look more like a stretched oval, an ellipse, pulling Mercury closer to the Sun at one end, then letting it drift farther away on the other. This elliptical orbit makes Mercury's journey feel uneven. When it's closest to the Sun, a point called perihelion, it speeds up. When it's farthest, aphelion, it slows down. It doesn't glide like Earth does. It hurries, then lingers, like it's catching its breath between heartbeats. This movement adds complexity to everything Mercury does. Its temperatures swing wildly. Its daylight hours stretch and bend. Even its sunrise pauses, because the planet doesn't spin and orbit in sync the way others do. And over thousands of years, this orbit slowly rotates. The ellipse itself turns, a process called precession. It's like the orbit is spinning around the Sun, not just travelling through it. A slow spiral, almost imperceptible, but always happening. So Mercury doesn't just orbit, it performs. A slow, poetic dance of ellipses and gravity, moving with elegance most eyes would miss. Why Mercury spins 3 times for every 2 orbits. Mercury's rotation is one of the strangest in the solar system. It takes 59 Earth days to spin once, but 88 days to go around the Sun. That creates an odd rhythm. For every 2 orbits it spins 3 times, a 3-to-2 resonance. This means Mercury's day is tightly linked to its year. One day there, from sunrise to sunrise, lasts 176 Earth days. Imagine that. The Sun rising just twice per Mercury year. It's more of a heartbeat than a clock. This odd lock happens because of gravity. The Sun's pull on Mercury is so strong, it distorts the rotation. Over time, Mercury settled into this stable rhythm, one that prevents too much wobble and keeps its core from tearing itself apart. What's fascinating is how precise this timing is. It's not chaotic, it's not random. It's like a musical rhythm, soft, slow, and steady, as if the universe gave Mercury a beat, and it's been dancing to it ever since. It's the kind of rhythm you don't hear, but feel, a deep pulse, in the silence of space. Why the Sun seems to stop and reverse. Because of Mercury's strange spin and orbit, something deeply odd happens in its sky. At certain times, if you stood on the right spot, you'd see the Sun rise, slow down, stop, reverse direction for a moment, and then continue rising again. It's a kind of celestial illusion, a product of the 3-to-2 spin-orbit resonance. Mercury's orbital speed overtakes its rotation at perihelion, so the Sun appears to hesitate, like it's thinking, like it's changing its mind. This isn't just poetic, it's real. A sunrise that flows backward, a moment when the sky forgets which way to turn, and then slowly resumes its course. Imagine sitting quietly on Mercury's surface, watching the horizon, the light growing, then pausing, the shadows stretching, then curling back, and all you can do is sit still and breathe. It's these moments that remind us space is not just distant, it's dramatic. It's not always loud, but it is always unfolding. And on Mercury, even the Sun is part of the performance. The slowest day you'll never feel. A single day on Mercury, from one sunrise to the next, lasts 176 Earth days. That's nearly half a year. You could celebrate 2 birthdays between morning and night. And yet, Mercury spins faster than Venus. It's not the slowest rotator, but its orbit and spin are so delicately balanced that the day becomes stretched, elongated, softened. It makes time feel like it's being poured, not counted. If you lived there, you wouldn't measure time in hours. You'd measure it in shifts of light, in long shadows, in the slow unfurling of heat, in the pause between movement. Mercury's long day means that one side bakes while the other freezes, and for weeks the twilight lasts. not like Earth's fleeting sunset, but an extended moment, a curtain slowly being drawn for days at a time. It's not a world of urgency, it's a world of patience, of long silences and slower rhythms. And maybe that's what makes it feel more like meditation than motion, gravity that pulls like a whisper. Despite its closeness to the Sun, Mercury's gravity is surprisingly gentle, only about 38% of Earth's. You'd weigh less than half what you do here. Jumps would be easier, steps would be slower. It would feel like walking through a quiet dream. This soft gravity has consequences. It means Mercury couldn't hold onto a thick atmosphere. It means dust and debris fall gently. It means sound doesn't carry because there's no air to hold it. But it also gives Mercury a kind of grace. Its surface holds history without disturbance. Its craters remain sharp. Its exosphere can exist, fragile and floating, because there's just enough pull to keep it close. Imagine standing there with your feet on stone and your body feeling light, as if the planet is letting you go, but still holding your hand. It's not gripping. It's not harsh. Mercury's gravity feels more like an invitation than a command. The ghosts of ancient volcanoes. You wouldn't expect volcanoes on a planet like Mercury. It looks quiet, cold, still. But if you listen closely to its surface, to the shapes of its land, you'll find signs of something long gone, ancient eruptions, frozen in time. Mercury's plains aren't just flat by chance. They were carved by lava, molten rock that once poured out from deep within, smoothing over craters, painting the crust with broad strokes of fire. But this didn't happen yesterday. It happened billions of years ago. Unlike Earth, Mercury's volcanoes no longer roar. The core has cooled, the crust has thickened, the pressure is gone, but the scars remain. Caldera-like depressions, wrinkled ridges, collapsed vents, all telling the story of a world that once burned brightly. Scientists believe that for hundreds of millions of years, Mercury experienced widespread volcanic activity, not towering mountains, but wide, slow floods of lava, oceans of molten rock reshaping its face. Now, those flows are frozen, black, still, silent, but they whisper, if you know how to see. They remind us that even the coldest worlds can carry the memory of fire, how Mercury cooled from the inside out. Planets are born hot, their cores churn, their surfaces boil, and their hearts pulse with molten heat. But over time, that fire fades. Mercury is a planet that has been slowly cooling for over 4 billion years, from the inside out. When Mercury was young, its core was molten. Heat escaped through the crust, fueling volcanoes, cracking the surface. But as the metal cooled, the core shrank. And as it shrank, the surface had to adjust, bending, folding, wrinkling like an apple left in the cold. This caused long cliff-like structures to appear. Scientists call them lobate scarps, ancient wrinkles where the crust pushed over itself. They stretch for hundreds of kilometers, silent records of a planet pulling itself inward. Unlike Earth, which still has a liquid outer core and tectonic movement, Mercury is more solid now. Its heat is quiet, its changes are slow, and its surface has settled into place, like cooling clay. But deep down, something may still move. A whisper of warmth, a molten thread, just enough to keep the story from ending completely. The plains that once ran with lava. Take a closer look at Mercury's vast, smooth regions, the intercrater plains and the smooth plains. To the untrained eye, they might look like deserts, flat, featureless, empty. But beneath that simplicity lies history, oceans of lava, now frozen. These plains are some of the oldest surfaces in the solar system. They formed as lava flowed out of fractures and fissures, covering ancient craters, erasing the past with molten light. And then they cooled, hardened, preserved. The smooth plains especially are younger than the surrounding terrain. They tell us that volcanic activity on Mercury didn't stop quickly. It lingered. It came in waves, a planet trying to balance its cooling heart with its restless crust. And what's haunting is how untouched these plains now feel. No winds, no rain, no erosion, just stone, perfectly still, like a photograph of a fire long gone. Standing on one of those plains, you'd feel the weight of time, the silence of solidified movement, the quiet of a world that once flowed and now watches the stars, the surface that wrinkled with time. If you were to walk across Mercury's crust, you might come across giant cliffs, scarps that rise hundreds of meters and stretch for miles. But they weren't caused by earthquakes or tectonic plates. These wrinkles were shaped by time itself. As Mercury's core cooled and contracted, the outer shell had no choice but to fold. It couldn't stay the same size while the inside shrank. So it crumpled, quietly, patiently, over billions of years. These scarps look like waves frozen in rock, curved ridges that sweep across the landscape, breaking through craters, cutting across plains. They are among the clearest signs that Mercury is still changing, even if we can't see it happen. Some of these cliffs may still be growing today, just a few centimeters every million years. Slow motion on a planetary scale, change that's more a sigh than a shift. It's one more way Mercury reminds us, not all change is fast. Sometimes the deepest transformations happen in silence. Crust. That's thicker than it looks. Mercury may be small, but its crust is surprisingly thick, around 100 kilometers deep. That's more than double the thickness of Earth's continental crust. It's a hard shell, wrapped tightly around a shrinking core. This thick crust was forged by early magma oceans. As the planet cooled, lighter materials floated upward, forming a rocky outer skin. Over time, volcanic eruptions added more layers. Impacts reshaped the surface, and little by little the crust became what it is now. Hard, uneven, deeply scarred. Its thickness helps preserve the planet's history. It resists erosion. It holds craters. It records every major impact with clarity. But it also tells us something about Mercury's cooling process, that it happened fast, that the crust formed early and locked much of the planet's heat inside. If you could slice Mercury in half, you'd see a small world built in layers: crust, mantle, core. But that outer crust is like armor, a final seal, a planet that built walls to keep its ancient story intact. And as we drift across that crust in thought, we feel something powerful, that even in silence, Mercury holds its memories close. Beneath every scar, there is a layer of something older, still waiting to be understood. A surface that shines like metal. When sunlight strikes Mercury, it doesn't scatter gently like it does on Earth. It bounces back hard, sharp, bright, direct. Mercury's surface is incredibly reflective, almost metallic, but not from polish, from rawness, from lack of air, from exposure. Its surface is made mostly of silicates and dark rocks, but they're covered in tiny iron particles, remnants of meteor impacts and solar bombardment. These tiny grains reflect light in ways that give Mercury a steely glint, like a coin under a spotlight. There's no atmosphere to soften the light, no clouds to filter it. On Mercury, the sun is harsh, brilliant, pure, and every surface reflects it back, without apology, like a mirror made of stone. But this brightness doesn't mean warmth everywhere. It just means exposure. Parts of the planet glow in the daylight, but just a few steps into shadow, and the temperature drops by hundreds of degrees. Mercury reminds us, brightness doesn't always mean heat, and surfaces can shine, even when what lies beneath is cold. The craters that never see the sun. Near Mercury's north and south poles lie craters so deep and positioned so precisely that sunlight never reaches them, not even once. These regions exist in permanent shadow, frozen darkness, on a planet closest to the sun. Because Mercury's axis barely tilts, less than 1 degree, the sun always hovers near the horizon at the poles. That means deep craters with steep walls never catch sunlight. They're like bowls left in the shade for billions of years. Inside these craters, temperatures drop to -170 degrees Celsius or colder. It's one of the chilliest places in the solar system, colder than Pluto, colder than deep space between stars. These shadowed basins are ancient, unmoving, and they offer a rare kind of stillness, the kind where nothing melts, nothing stirs, and time itself seems to pause. And in those shadows, scientists found something unexpected, something that shouldn't exist on such a sunlit world. Ice in the closest planet to the sun? Yes, Mercury holds ice, real frozen water, hidden inside its shadowed craters, not puddles, not lakes, but bright frozen deposits, like frost buried in stone, tucked away where the sun has never reached. Radar data from Earth and space missions confirmed it. Reflections bouncing off Mercury's poles match the signature of water ice. Clean, cold, likely delivered by ancient comets or formed by chemical reactions in space. It's a contradiction that feels like poetry. Ice on the planet nearest the sun. It shouldn't be possible. And yet it is. Not by accident, but by delicate balance. The walls of the craters shield it. The lack of atmosphere protects it. And time preserves it. The ice may be billions of years old, untouched, pristine, older than Earth's oldest fossils. A message in a bottle, written before humans even existed. Mercury whispers a strange truth here, that even in the hottest places, the coldest secrets can survive. Why sunlight can't reach every corner? The sun dominates Mercury's sky. It appears more than 3 times larger than it does on Earth. Its heat is overwhelming. Its light is intense. And yet, not every corner of Mercury sees it. Not every surface is warmed. This is because Mercury's rotation is slow and its tilt is nearly zero. That means at the poles, sunlight never climbs high enough to shine into deep craters. It skims the horizon, circling like a ghost, never stepping inside. Even at the equator, shadows stretch long. Craters near the rim cast dark voids that last for weeks. There is no twilight on Mercury, only harsh light or deep shade. It's a world divided by extremes, bright or dark, boiling or frozen. There is no in-between. And that's why the idea of ice makes sense. If you know where to look, sunlight may rule most of Mercury, but in certain places, darkness has always won, not by force, but by quiet position. The eternal darkness holds ancient clues. These permanently shadowed craters, these wells of cold and silence, may be more than just icy storage rooms. They might be libraries, preserving clues about the early solar system. Dust, molecules, chemistry untouched by time. Inside there could be organic compounds, precursors to life, trapped before life ever began, delivered by comets, stored by shadow, and protected by the absence of heat. A museum of cosmic ingredients, frozen before memory began. If we ever send landers there, they'll have to tread softly, gently. For what they'll touch isn't just ice, but a timeline, a preserved page from the universe's diary, written in frost and sealed in rock. It's humbling to think the smallest planet holds some of the oldest secrets, in the coldest corners, in the deepest silence, and as we drift away from those craters in thought, we realize Mercury isn't just spinning in space, It's waiting, watching, holding a breath. No sunlight can steal the magnetic field that shouldn't exist. Most small planets lose their magnetic fields. Over time, their cores freeze, their energy fades, and the invisible force that once protected them disappears. But Mercury? Mercury still has one. Faint, but real. And scientists were stunned when they found it. Back in the 1970s, the Mariner 10 spacecraft flew past Mercury and detected a magnetic field, just 1% the strength of Earth's, but enough to shape the space around the planet. Later missions confirmed it. Mercury wasn't as dead as it looked. This discovery shook assumptions. Mercury was small, old, close to the Sun. By all logic, its inner dynamo, the engine that creates magnetic fields, should have stopped long ago. But somehow, it didn't. Deep inside, something is still stirring, slowly, quietly, like an ember beneath ash. And that invisible field, though weak, stretches thousands of kilometers above Mercury. A ghostly shield crackling softly against the solar wind. A liquid core in a frozen world. The reason Mercury has a magnetic field is even more mysterious. Its core, or at least part of it, is still liquid, molten, alive. A swirling sea of iron and nickel beneath the solid crust. That's astonishing. For a planet this small to retain inner heat after billions of years is like finding steam in a long cold kettle. It shouldn't be possible, and yet Mercury holds it. We believe the core makes up about 85% of Mercury's radius, an immense dense heart. It might have a solid inner core, a liquid outer shell, and perhaps even a thin mantle above that. A planet built inward, like a metallic onion. And that liquid motion stirs Mercury's magnetic field into life. Even now, it's not powerful, it doesn't block everything, but it proves one thing. Mercury hasn't stopped yet. It still moves, even if we can't see it from the surface. How Mercury's magnetosphere interacts with the Sun. Even with its faint magnetic field, Mercury has a magnetosphere, an invisible bubble that interacts directly with the solar wind. But unlike Earth's protective shield, Mercury's magnetosphere is chaotic, twisted, torn open by the Sun's power. When the solar wind, a stream of charged particles, slams into Mercury, the planet's magnetosphere flares and shifts. It doesn't deflect everything. In fact, solar particles often breach the surface directly, leaving Mercury vulnerable and scorched. But this makes Mercury the perfect laboratory, a place where scientists can study what happens when solar storms hit a planet up close. Where light and magnetism meet head-on. There are bursts of X-rays, currents in the magnetic field, a dance between fire and metal, silent and unseen. And even though Mercury doesn't have an atmosphere, these interactions still matter. They leave scars on the surface, they shape the exosphere, and they whisper something deeper, that Mercury, though silent, is never truly still. Magnetic tornadoes in the silence. On Mercury, scientists have detected something wild, magnetic tornadoes, tiny twisting tunnels of magnetic energy, created when the solar wind tangles with the planet's magnetic field. These tornadoes, or flux transfer events, are brief invisible spirals. They punch through Mercury's magnetosphere and allow solar particles to funnel down toward the surface, unleashing sudden bursts of energy. It's strange to imagine, a place with no air, no clouds, no storms, and yet above it, invisible whirlwinds spin, tugging at the magnetic skin of the planet. They happen in seconds. They vanish without trace, but they carry power, shaping how Mercury's surface gets weathered, how its exosphere behaves, and how the Sun touches it more deeply than any other planet. In a world so quiet, even the chaos has rhythm. the mystery of Mercury's offset magnetic field. One last twist. Mercury's magnetic field isn't centered, it's tilted, shifted northward by almost 20% of the planet's radius. That means the magnetic field is stronger in the north and weaker in the south. No one fully knows why. Some theories suggest asymmetry in the core. Others think it's how the outer layers cooled, but no model explains it perfectly. It's one of those planetary puzzles that makes Mercury feel even more personal, like it holds secrets it's not ready to share. This offset has real effects. It changes how charged particles strike the surface. It shapes where ice can form near the poles. And it tells us that even deep beneath Mercury's crust, things are not symmetrical. In the silence, imbalance remains. And maybe that's the quiet beauty of Mercury, that nothing is perfect, but everything is still moving.